Atoms. And first of all, J.J. Thomson model. According to this model, an atom is a sphere of positive charge of uniform charge density about 10 raised to power minus 10 meter in diameter, in which negative charge electrons are embedded like plums in pudding. This model could not explain the origin of spectral line in the form of series and could not explain the alpha scattering through large angle. Alpha particle is a positively charged particle having mass equal to that of helium atom and positive charge equal to twice that of an electron. In Rutherford alpha scattering experiment, a beam of alpha particle from bismuth is allowed to fall on a thin gold foil. Most of the alpha particle pass through the gold foil undeflected. Some of alpha particle about 0.14% were deflected through small angle. A few alpha particle about 1 in 8,000 were deflected through 90 degree or more. The scattering was due to Coulomb interaction of alpha particle with positively charged atoms of gold foil. Conclusion is that atom has a lot of empty space since most of the alpha particle passed undeviated. All of the positive charge and the entire mass of the atom is confined in a very small central core called nucleus. The minimum distance of a point from the nucleus up to which an energetic alpha particle traveling directly toward the nucleus can move just before coming to rest and then retrace its path is known as distance of closest approach. Impact parameter is defined as the perpendicular distance of the velocity vector of the alpha particle from the center of the nucleus when it is far away from the atom. Postulates of Rutherford nuclear model. Almost all the mass of the atom and all the positive charge of the atom are concentrated in a very small region called nucleus. The size of the nucleus is very small as compared to size of the atom. The negative charge electron revolve around the nucleus. The necessary centripetal force is provided by Coulomb force of attraction. Number of electron is equal to number of protons, so atom is electrically neutral. When electron revolve around the nucleus, it continuously accelerates toward the nucleus. Its energy continuously fall and its radius goes on decreasing. It should ultimately fall into the nucleus. However, it never happened, so Rutherford failed to explain the stability of the atom. In Rutherford model, electron can revolve in orbits of all possible radii and hence it should emit continuous energy spectrum. However, atom like hydrogen possess line spectrum. Therefore, it failed to explain the complex spectrum emitted by an atom. The spectrum of electromagnetic radiation emitted or absorbed by an electron during transition from one energy level to another energy level of an atom is called atomic spectrum. Series of lines of various wavelength emitted by an atomic gas or vapor usually excited by electric current pass through it is known as line emission spectrum. The spectrum produced by the radiation emitted by an excited element is known as characteristic spectrum of the element. When white light passes through a gas, then the spectrum of the transmitted light observed with spectrometer shows some dark line which replace some bright line seen in the emission spectrum of the gas. This type of spectrum is known as line absorption spectrum. Postulates of Bohr model of hydrogen atom. An atom consists of central core called nucleus where whole of the mass and positive charge is supposed to be concentrated. An electron revolve around the nucleus with definite fixed energy in a circular stable orbit without gaining or losing energy. Such orbits are called stationary states of electron are also known as energy levels. Electron can revolve only in those energy levels in which its angular momentum is integral multiple of h upon 2 pi. An electron can emit energy in the form of photons or radiation when it jumps from higher energy level to lower energy level. We calculate radius of orbit, speed of electron and energy of electron. Then we study the energy levels of hydrogen atom. The process of absorption of energy by electrons so as to raise it from lower energy level to some higher energy level is called excitation. The energy required to raise an electron from its ground state to excited state is called excitation energy. The potential difference through which an electron must be accelerated so as to just raise it from ground state to excited state is called excitation potential. The process of knocking an electron out of the atom is called ionization. The energy required to knock an electron completely out of the atom is called ionization energy. Limitation of Bohr's model. It could not explain the spectrum of complex atoms having more than one electron. It could not explain the fine spectrum of spectral lines of Balmer series. It does not give any indication regarding the arrangement and distribution of electron in the atom. It could not account for wave nature of electron. It could not explain the splitting of spectral lines into number of spectral lines under the effect of magnetic field and electric field. It does not tell anything about the relative intensity of spectral lines, some numericals, and at last, thanks for watching this audio video of notes.